Okay, so I think that number 18 is super hard. This might be a good question to skip and go ahead to 19 and 20, see if you can pick up those points much more easily, and then if you have time, come back to this, because this is kind of time consuming. I'm gonna do it kind of a longer way at first, but there is an algebra way that's a little bit shorter. But I think if you're confused by this, the arithmetize strategy is really gonna help you kind of get unconfused, but you have to be really confident in it because we're gonna hit some annoying math along the way. So let me show you what I might do to get unconfused by this story. So I'm gonna arithmetize, which means I need to understand this story with numbers instead of this hypothetical situation. So Juan purchased an antique that had a value of $200 at the time of purchase. Great. So at year zero, it's worth $200. Awesome. Each year, the value of the antique is estimated to increase 10% over its value the previous year. The estimated value of the antique in dollars 2 years after purchase can be represented by this expression where A is a constant. So I need to understand what this thing's value is in 2 years. And I can do that math even without a calculator fairly easily. So in year one, it's going to increase by 10%. This is the kind of math you should really be able to do in your head. 10% means just I move the decimal place, and so I'm going to add in whatever that moved amount is. So if I have 200, 10% of 200 means I take the decimal place and I move it backwards 1. So 10% of 200 is really 20. That is something you should be able to do in your head, ideally. And so now I add that in to my original 200 and I have a new price of $220. But in the next year, it doesn't go up by another 20, so it's not going to be $240. It's going up by another 10%, meaning that, again, I need to do this thing with the decimal place. So now 220, we move that decimal place 1 to the left backwards, and we get that 10% is now a different number, $22. And that's what happens with exponential growth, is as we add more, we add more. It gets bigger faster. So we add in $22 this time, and we get a total of $242. Okay? So we can use that number because we were given this other equation. The price, the value of the antique after 2 years can be represented by this equation, this expression, where A is a constant. So we know the price after 2 years, it's 242. So 242 is equal to this expression, 200 times A. And it's obvious how we need to solve for A here. We can just divide by 200. And you might be like, oh no, 242 divided by 200, I can't do that. Well, we could do long division. That's totally acceptable. Or we could just try to reduce a fraction. Because I know that if I can pull out a common term, I should be able to make these numbers smaller, and maybe it makes it easier to do the division, or maybe I can pull out another number. Like, I don't really know, but I do know that both of these things are divisible by 2. And so if I pulled a 2 out, I'd have half of each. So that's half of 200 is 100, obviously. And then half of 242 is 121. And now, again, because of the way the decimals work, this math is actually really easy. We're dividing by 100 means now we move the decimal place 2 places, not just 1. So instead of 121, that decimal place goes 1, 2, and so it ends up right there. So A is equal to 1.21, and that's the final answer. Again, we could have done long division. We would have gotten the same place. But a lot of times in the SAT, they kind of design questions so that these little arithmetic shortcuts can help us along the way, even though the numbers look like they're going to be bad. There's little things that make it not so bad. So you have to have that confidence in your own arithmetic ability and the way the SAT designs questions to be able to do that. Let's look at another way, though, to solve this question that's more based on formulas. So if we have exponential growth, which is what this is, we know that there's a way to figure out exponential growth equations. So the way that I teach my students is I use what I call the open formula. Open, like the word open. And it's basically a way to remember how to structure an exponential equation. So the original amount times a percentage. And in this case, since it's a percent increase, we're going to do 1 plus the percent. And that's to the t, time, equals, the e, the new amount. Okay? So based on the equation, we can fill in a lot of this stuff. We know the original is 200. We know that 1 plus p is going to be 1 plus, let's do 0.10. It's 10% as a decimal, 0.10. And then to the t, well, it says 2 years have passed. And that's supposed to be the final amount. So we can say, we can keep it as the new, or we can just say the 200a that they gave us in the question. And now we can just simplify. 200 times, well, that's 1.1 squared is equal to 200a. Because of the algebra, we can cross out those 200s. And now it's really just 1.1 squared, which, again, if we're clever with arithmetic, isn't hard. That's really just 11 times 11 with 2 decimals. But we could do it the long way if we needed to. But we're going to get, either way, 1.21 is equal to a, which is what we got before. Maybe one way for you is a little bit easier than another. I don't really know what most people are going to see with this question. I know that I see it as an arithmetized question first because that's a very strong habit for me from having done the SAT for as long as I have. Maybe both are confusing. I don't know. It's a hard question, and that's, I guess, the point I really want to make is that this is an okay one to skip. Maybe take a random guess and then move on, see if you can pick up the points in 19 and 20. There's nothing wrong with kind of moving around once you get to these free response ones and trying to pick up points wherever you can. You don't need to do 18 to try to get 19 and 20. Be a good user of your time and skip around as needed.